Okay, so today we're going to be learning how to solve using the quadratic formula. We've already learned how to solve by factoring, meaning what that means is we solve for the x-intercepts or the roots of the solutions. They all mean the same thing, but we factor the problem, we set each factor equal to 0, and whatever we get, those are our solutions. However, basically you can't factor everything. In fact, most parabolas can't be factored. We have to specifically make problems that can be factored. So what we have is a thing called the quadratic formula. This works for all x squared problems, whether they could be factored or whether they can't be factored. So you can use it instead of factoring anytime you want. But also those problems you can't think of the solution for the diamond problem, this can step in and be a backup solution. I like to think of it as a spare tire. It's something that you need to make sure you have in your trunk, in your tool chest, however you want to say it. But you don't have to always use it. But if you need it, you definitely need it. So there's going to be problems where you can't think of the sides of the diamond problem. I want you to be able to fall back on to go to the quadratic formula anytime that happens. Okay, we've already looked at these two equations. The one on the left is what we call the vertex formula. Okay, you take b from your x squared problem and you divide it by 2a. You take the opposite and divide it by 2a. On the right side we have what's called the discriminant. What the discriminant does for us is it determines the number of solutions. We're now going to combine these two things together. So notice all I really did was put the 2a in the middle of a big fraction bar. Okay, and I added, if you think about it, the only thing I really added here is I added this plus or minus right there. Everything else was what we already had. Okay, in red here we have the discriminant, d. Okay, on the bottom here we have, I'll do this in green, we have the vertex formula, negative b over 2a. So all we've really done is brought those two things together with a plus or minus in the middle. This plus or minus sign is how we end up getting two different answers for our two roots that are possible. Remember, you could have 0, 1, or none. Okay, this is called the quadratic formula. And this is something you're going to need to memorize. So if you haven't memorized it yet, you need to make sure you take the time to do that. As I said before, the plus and minus is how it gives us our two possible answers. If it's positive, we end up with two answers. We end up with the opposite of b plus some number, and we end the opposite of b minus some number. So that's how we get two things. So for example, let's say the top is negative 5. Negative 5 plus 5 is different than negative 5 minus 5. So you end up with two different things. If instead it's 0, then you're only going to end up with one thing. Because when you take negative b plus 0 and negative b minus 0, it doesn't change. So really what happens is once you do this, once you get 0 in the discriminant, all this part here doesn't matter anymore. All of this is gone, and you're just left over with basically the vertex, which makes sense because when the discriminant is 0, that's a parabola that hits just at the vertex. Well, what are we solving for? We're solving for the x-intercept. Well, there's your x-intercept right there, which is the vertex. Remember, this is the x part, and to get the y part, we usually have to plug it in, but for this problem, it's equal to 0. If it's negative, then what happens there is we end up with the square root of a negative number. We can't take the square root of a negative number, so therefore there is no x-intercepts, no solutions. Alright, so let's go ahead and try some. Just like before, what you're going to do is you're going to identify your A, B, and your C. I'm going to show you two different ways to do it. The first way is to use the whole entire quadratic formula and solve it all at once. So the first thing we would do here is we would fill in all the parts. It's a lot. There's a lot of numbers to plug in. You can see I plugged in B twice, A twice, and C once. From there, there's a whole bunch of simplifying to do. I'm going to need to simplify this part here and turn that into a positive 4. And I'm going to need to do what I already did in the discriminant here, just like before with the discriminant, and simplify all of that inside of there. And I also need to simplify down here and make sure that I get a 2 or 2 times whatever number is in place of A. So there's a lot to do. You can do those as one individual step, or you can do them as separate steps. Okay, so as you can see, I simplified all those pieces that were just done on that paper right there. It's a lot of work. So from there now, I'm going to take the minus 84 and turn that into a plus 84. And then 16 plus 84 is 100. As you know, square root of 100 is 10. And now from there, what I do is I simplify the problem by breaking it up. So I'm going to get 4 plus 10 over 2 and 4 minus 10 over 2. You always are going to take this thing and break it up into two pieces, 1 and 2. (14 over 2 is in fact 7, and negative 6 over 2 is negative 3. So my answers are 7 and negative 3. My thing is I find doing the whole quadratic formula kind of difficult. You know, I would prefer to be able to break this up into two small pieces, or at least reasonable sized pieces. We've already found the vertex before, and we've already done discriminant many times, and that was something that was pretty easy for you guys. So a second way of doing it that I prefer is to do this problem in two pieces. Always we have to identify A, B, and C. What I'm going to suggest we do is this. Take the discriminant and do that part first. Here's why. If you get a positive number, then you go forward. Okay, positive number means two solutions, solve the problem. If you get a negative number, you're done. There is no solution. Why would you go ahead and go through all those steps just if you're going to get a negative number? So I would go ahead and do this part first. If you get 0, remember it's just negative b over 2a, so you could skip that whole process too. So let's look at how that looks in some examples. So we're going to start off with negative b over or b squared minus 4ac. So first thing I do is I plug it in just like we did in class. I use my parentheses. So I'm going to go 7 squared is 49. 4 times 3 times negative 4 is negative 48. Those are now going to get added together, and that's going to turn into 97. Once I get that, I realize, hey, there's two solutions. If I get two solutions, I'm just going to simply use that square root of 97 in the rest of the problem. So it kind of saves you having to organize everything at once. Now I'm going to go ahead and do that. Negative b will be negative 7, and 2 times 3 is 6 on the bottom. And that's basically it. Now all I have to do is take that answer and break it up into two separate answers, which are negative 7 plus root 97 over 6 and negative 7 minus root 97 over 6. Remember, plus and minus came from the splitting up of that part there. It's necessary for you always to split the problem up into two pieces if there are two solutions, which happens every time that this is a positive number. So that's how we break it up, and your answer is done. Now, a lot of you guys get confused and think, oh, but what am I supposed to do with that 97? Nothing. You don't know what the square root of 97 is. It's a little bit less than 10. That's about all you know. So I don't want a decimal. I just want you to leave it like that. If you are doing a problem that was like, say, in a science class or something, you may have to use your calculator to do the rest of the problem. But really, you can use a calculator for it. You don't need to do any more arithmetic or any math to show me that you know how to do it. What I'm looking to see is, do you know how to plug the numbers in? Do you know how to break the answer up into two answers? And you know how to write your answer? Remember, these are now your solutions or your roots or your x-intercepts. If we wanted to call it an x-intercept, we would simply write it as a point with 0 for the y. Okay, let's try another one. All right, so we're going to plug in A, B, and C. Okay, B goes into the B spot, A and C. So we end up with 81 minus 4 times 2 times 3, which is 24. 81 minus 24 is again positive, which is positive 57, and that's going to get used right into the problem. Lastly, we're going to take that B and that A and put them in there. Notice that the negative B made a negative 9 into a positive 9, and 2 times 2 on the bottom was 4. Last thing to do, split that problem up into two pieces, and you're done. It's pretty simple when you go through the process. It's a little weird. The problems look strange, and you're doing some arithmetic, but it's possible to use a calculator when you do these. Okay, we're going to do another problem here. A is 1, B is 6, C is 9. As you can see, plugging them in, you end up with 36 minus 36. That's 0. Okay, this is why I want you to be smart about this. I'm not just going to go ahead and go plug that 0 in. I'm going to say, wait a second, that means one solution. When it's one solution, it's just negative b over 2a, and all I have to do from there is plug in my negative b over 2a, which is x equals negative 3. Remember, we're expecting to only get one solution when you get a 0 in your discriminant. Okay, next example for you guys here. So here we're going to get negative 5 times negative 5, which is 25, minus 4 times 2 times negative 3, which is negative 24. Be careful here. This is where people tend to lose their negative signs. This is why I really recommend, just like we did in class, that you put that bracket in there. Okay, you bring the negative sign down, and then you can see that gives you a negative 24. Negative and negative turn into a positive, so that gives us a positive 49. Now you know the square root of 49 is 7, so we have to actually use that 7 in our problem. You can't just leave square root of 49. Now we have that. We're going to substitute in our opposite of negative 5 is positive 5, and 2 times 2 is 4. And we take the problem and we split it up. Splitting the problem up, we get 5 plus 7 over 4, and 5 minus 7. 5 plus 7 is 12. So you divide that and get 3. And 5 minus 7 is negative 2, so you simplify that and get negative 1/2. So as you can see in this case, we actually end up with two answers that end up being numbers that we can actually calculate. That's going to happen anytime you get a square root that you actually know. Basically, if the number comes out to be a whole number, that means you could have factored it to begin with, meaning we could have done a diamond problem in a rectangle, and maybe that would have been easier. My rule of thumb in general for you guys, because you're so good at those factoring problems now, is to try to factor it, and if you can't think of it, just go straight to your quadratic formula, because it always works. If you just couldn't think of it, it'll come out nice and neat like this one. If not, then you never would have found it, and you can get a nice answer that's maybe a weird square root, but that's okay. Okay, the last example we're going to look at is, of course, going to be one that ends up with no solution. What you do is you plug in your a, b, and c, and as you go through the steps, you end up with square root of negative 11. Now, what students tend to do is they tend to just take this answer and throw it right in there and do the problem. The issue is you're supposed to look at this right here and say, wait a second, never mind. I can't do that part anymore. Okay, what that really means is no solution, and that's how you should answer the question. So hopefully this gives you an idea of how to do quadratic formula problems. Again, it's a review. We've done it in class. So hopefully this helps you guys out and gets you prepared for your final.